Oh, okay. What?
I'll be out in the village.
Yeah, out in like the football stadium.
So what is the
And
School Spirit, yo. Haven't you ever seen like, what's it like, High School Musical? Woo! Yeah, it's a teen movie. This is your guys' childhood, okay? You guys are gonna look back and be like, wow, I miss high school. That's like what it used to be like. Now you guys are all just antisocial. I don't know. Your coach is gonna tell you. Anyways, so you need to open your computers. You go to Canvas. In 4.3, there is a link, and it's gonna open this little program, which is GeoGebra. Does everybody have it open? Watch your points for number one while you're waiting for your computer to load.
oh, are you a joke? Yeah, I thought it would be. Are you guys?
Let's hold on.
What for?
And you get 4.3 with the link. Okay, so for rotations are the hardest. Translations. So there's different transformations. Translations are the easiest. That's where you shift left, right, up, down, easy, low, squeezy, nice. Okay. Reflections got a little harder, but not too hard. You literally just count from the left to the right, to the right to the left. The only ones that you need to use the rule for, that you need to remember, are whenever you have lines that are diagonal. When you have a positive slope, it just flips the coordinate. Whenever you have a negative slope, it flips the coordinate and makes a negative. The rotations are the hardest one. There are 4 transformations. This last one we're going to save for next week. But rotations are the hardest. They mess with your brains the most. So this will help you for today. Obviously, can't use this on the test. But this program will help you visualize how it's moving. Some people understand what a rotation means. It's spinning. Some of you don't understand like visually what's happening. So what you're going to do is we are going to, on our little graph, we're going to start by moving this little random dot. Everybody see this little random dot down here? This little random dot, this is your rotation point. So if I just move it randomly somewhere, it doesn't matter where, and I spin this rotation, oh, I got to click these little boxes. If you click this little box, boop, it's going to pop up your original and the rotation. You're going to see that it spins around that point. Okay, you got to click all 3 of these little boxes. So it's spinning around that point. For today, we are going to keep our origin at 0, 0. So where your rotation point is, you're going to move this little random point to the origin. Where's the origin? 0, 0. So move that point to 0, 0. Now take a second. If you play with your rotation, you're going to see it spins around 0, 0. So for today, and also on your EOC, it always spins around the origin. The district makes us do a random point. So we'll do a random point for 2 days, but it is not on your EOC. They just are silly gooses and don't know what they're doing, to be honest. But whatever. They should know what they're doing because they're district people. So we are going to make our triangle that's on our online program look like the triangle that's for number 1. So we're going to drag each point and we're going to plot them in the proper spaces. So for one of the points, it's going to be at 4, 1. So drag one of your vertices to 4, 1. Oh, snap. We're going to drag the other one to 2, 4, which I think there's one already at 2, 4. There is. So the last one is at 2, 0. So we're going to drag it down to 2, 0. So it should look like the one on your graph. So for number 1, we're going to rotate it 90 degrees CCW, which means counterclockwise. So there's 2 directions. Well, a clock does not go 2 directions, but one is clockwise. That's to the right. The other one is counterclockwise, which is to the left. This program only goes counterclockwise because normally you only go counterclockwise. So we're going to drag our rotation to 90 degrees. Skirt, 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 skirt. There we go. Okay. So how did A prime, where is A prime at now on my graph? A was 4, 1. Where is it now? -1. +4.
B prime started all the way at this tippy top. When you spin it, where did it end up? -4, 2. And then C prime. 0, 2. So take a minute, plot your new points on your graph. Should match your little online graph. So -4, -4 is A prime now. B prime is -4, 2. C prime is 0, 2. And then we're going to color it in with one of our colored pencils. So that way we know that that is the final answer. So when you rotate it 90 degrees, and you only go in 90-degree increments. So there's 90, there's 180, which is 90 twice, and there's 270. Why do we not go 360? Because it's the same. It's just going to end up in literally the same spot. So we don't do 360 because it's just going to end up in the same spot. So if I compare my coordinates, so now if I take a second and I look at the actual coordinate points, A was this and it changed to this. B was this and it changed to this. C was this and it changed to this. What is the pattern? Does anybody notice what happened? Yes. So it flips. Y goes in the front, X goes in the back. And then which one became negative? The front and the back. The new X, which is the old Y. So two things happen. Whenever it's 90-degree counterclockwise, it flips the coordinate and the front changes the sign. So on your actual graph, 90 degrees is one quadrant moving. So we are going to take our other color pencil and we are going to show that we're going one quadrant. So we started here, we moved one quadrant, 90 degrees. If I spun all the way around, it would take me to the same spot. So we're going to see that it goes in like 3 options. 90 is 1, 180 would move 2 quadrants, 270 would move 3 quadrants. 4 quadrants would be 360, but we don't do that. Boom. So let's move to number 2. Okay, I'll leave it here for a second. For your online program, I think it's easiest if you just refresh this so it goes back to the original. So refresh this little button. And then start from scratch. You're going to move your origin to 0, 0. Make sure you click this little extra box so you can see the new one and the old one, and put your rotation back at 0. So that way you can start from scratch. We're going to change our points to match the points on problem number 2. So problem number 2, we have these coordinates. We're going to plot them on our graph, on our paper, and we're also going to put it online. So once you got your graph and you got your online graph matching the same, this one's going to go 180 degrees counterclockwise. So you're still going to the left because it's counterclockwise. We're going to move 180 and you're going to notice that it's going to move 2 quadrants because 180 is 90 twice. 90 would move it 1 quadrant. 180 is going to move it 2 quadrants. So I'm going to rotate it to 180. That would be 90. Oh my gosh. And then we're going to move it again. 180. So A, yours looks different. Is your point at 0, 0? So if your graph looks different, it might be just because your rotation. So type A, B, and C. Ready to move, ready to go. So where's A prime at? Zero, -3. Or B prime. B prime was up here. Where is it now? Where is it? -3, -4. And then C prime? Perfect. -4, -2. So whenever you're plotting these, did they switch places? Did they flip the coordinate? No, they did not. What happened this time? They just all became negative. That's it. So this one did not flip. All they do is become negative. So for our rule, we're not going to switch X and Y. X is going to stay X, Y is going to stay Y, but it is just becoming negative. Now, if they were already negative, what would happen? They would just become positive. So whenever you have 180 degrees, technically, if you start here and you go 180 degrees counterclockwise, boop, boop, that's going to move 2 quadrants. If you move 180 degrees clockwise, boop, boop, that's going to move it 2 quadrants as well. So 180 actually has a nice rule because that rule is the same for clockwise and counterclockwise. We are going to put in our little arrow in our other color. It's moving 2 quadrants because it's 180 degrees. So we're going to use the program for the last question, which is problem number 3. So we're going to reset our little graph again. So refresh it from scratch. Boop. Make sure you check all 3. Move your rotation back to 0. Move your coordinate back to 0, 0. And then we're for number 3, it's still a triangle. And this time we're going to go 270 degrees using our new points. So take a second, plot your new points on your graph, and then we're also going to plot it on the omelet. Oh, this one's really small. It's just it's a bitsy one. 4, 1, 2, 4, 3. Okay. So we're gonna go 270. 270 is the largest. So it's almost going all the way around in a complete circle, but it does not go all the way around. It's gonna go 3 quadrants. 90 is 1 quadrant. So if I scoot it over to 90, 90 is like here-ish. Yeah, 90's there, whatever. 90's there. 180 takes it to the second quadrant, which is down here. Ugh. And then 270 is going to take it to the third quadrant all the way over here. So take a second. We got to match up our letters. So A was 3, 2. Where is A prime now? Two, -3. B was for 3. Now what's B prime? 3, -4. And then C prime. One, -4. So we're going to plot our points on our graph. We're going to shade it in so that way we have our new triangle. This one's really small. 2, -3. $270 moves 3 quadrants. So whenever I use my other color, it's moving all the way 3 quadrants. 270. So if you're comparing the numbers, this is the last rule that we need to make up. Did they flip spots? Yeah, they flipped. Okay. So X became Y became X. So they flip-flopped. And then which one became negative, the front or the back? The back. The old X, new Y. So for our rule is going to be Y and then X in the back, but X is negative. So that is for 270 degrees counterclockwise. So like we kind of talked about, a circle is going to lead obviously in the same direction, whichever way you go. It's just a different amount. 180 is going to repeat itself. If I have this and I did 180, 1, 2, or if I did 1, 2, 180 is still going to end up down here no matter what. If I go 270 degrees counterclockwise, this would be the same spot if I went 90 degrees clockwise. If I went 1 to the right. If I go 90 degrees counterclockwise, that would be 270 degrees clockwise. So the rules repeat themselves. So we're going to fill out this nice little chart. This chart is very important. By May, you need to have these rules remembered. These will be questions on your EOC. These are the ones that you need to have the rules for because you will not be given these. This is not on the formula sheet. So I'm going to move this because you can use that later if you want, but for now, we're just going to use the rules. So this is our cute little chart. Counterclockwise and clockwise, they repeat the rules in the middle. So for 90 degrees counterclockwise, what did we say our rule was for the first problem? Negative YX. That would be the same rule for 270 degrees clockwise, because if I go one quadrant to the left, that would be the same as ending up 3 to the right. Okay, 180 is 2 quadrants, and it's the same no matter which direction you go. 2 to the left or 2 to the right, you're going to end up in the same one. So what is our rule for that one? Perfect. Negative X, negative Y. This is the only one that they do not flip. They just turn negative. And then the last one is 270 counterclockwise, which is the same as 90 degrees clockwise, which is what? Y. Perfect. And then pick a color. This is important. So we're going to outline this. This is important. By May, you need to have that burnt into your brain. These will 100%, no doubt about it, be on your EOC. There's some things that I'm like, it's going to be on there. It's part of the standard, but like, is it on there? This will 100% be on there. So that's this same little chart right here is your rotation chart. These are important. It will be burnt into your brain. So now we're not going to use the online thing. If you want to use the online thing for later, you can totally do that because it's kind of like a cheat system. But we are going to just use the rules. So for number 4 on here says rotate the following 90 degrees clockwise. So we're going to start by plotting the originals. -2, +3 is A. B's at -7.5. 1, 2, 3, 4, 5. C's at -4.7. So plot your originals. It looks something like that. And we're using the rule for 90 degrees clockwise. So we're not going to the left. We're going to the right because this time it's clockwise. So if you look at your little chart that we just made, 90 degrees clockwise, what is the rule? No, that's 90 degrees counterclockwise. Y negative X. Is that what you said? Why? Oh, okay. I like, they just all sound similar. Y negative X. So Y negative X is 90 degrees clockwise. It's technically the same as 270 degrees counterclockwise. The rules repeat themselves. So if this was the original point, I'm doing 2 things. I am flipping it and I'm changing the symbol in the back. The back symbol changes. So I'm going to start by just flipping the coordinate. So if I flip it, it's 3, -2. I flipped it. Now I change the symbol in the back. So is this still -2? No. 2 negatives make a positive. So you can either leave it as +2 or I'm just going to make a plus sign. We're going to do the same thing for B. We're going to flip it. And we're going to change the symbol either in the back or in the front. So if I flip it, it's 5, -7. And then I change the symbol in the back. So what happens? It turns positive because it's already negative, so it turns positive. So what would C's coordinate be? 7, +4, because the two negatives will turn into a positive. So it turns into a plus sign. You don't like the plus sign, then you don't have to put plus signs. So we're going to plot it, and you're going to see it went 90 degrees clockwise, which is one quadrant to the right. So it still preserves distance and angle measure, literally exactly the same. It's just spinning around 0, 0. So it went 90 degrees this way. All right, 90. So try number 5. Start by plotting your points. Has anybody figured out the rule for 270 degrees? Yeah, negative yx. Sorry. Negative yx. Good. So 270 degrees clockwise is the same technically as 90 degrees counterclockwise because they repeat. So you're doing two things. Take a second, you're flipping your coordinate, and the front changes its sign. So where should A prime end up? -3, 2. Where's B prime? -5, 7. And then C? -7, 4. So when you plot this, it's moving technically 3 quadrants to the right, which spins all the way up back around. So it's going to end up over here. -3, 2. -5, 7. 1, 2, 3, 4, 5, 6, 7. How do we feel? Not too bad, not too bad. So it's going to the right. 2, 7. So that's what it should look like. Venice, Venice. Do you want to do one more together or you think you got it? Huh? It does look like pumpkin. It's like those pumpkin eyes. And now it's got a happy face too. Try number 5 on the back. Go to number 5. Yep, go to number 5 on the back. This one does not have a little cute chart. You're gonna have to write the coordinate points out to start. Okay, so they gave you the picture, not the points. So start by writing out D, G, and F. Doesn't matter the order in which you write them. Write the coordinates, use the rule, change the coordinate. They would change because 2 negatives make a positive. So what's your rule for 180? Negative x, negative y. You are not flipping it. You are changing the symbol. If it's positive, it's negative. Negative, it's positive. Because two negative, no positive. It should look like it's moving two quadrants. You're done. So what's d prime? Oh, you wrote them in a different order. So it should be 5, -5, and then g prime. 5, -1, and then f prime. 10, -2. Perfect. So it should make the same shape just over here. 3 prime, 5, -1, 2 prime, and then 5, -2. F prime. 2, 2, 3. Nice, nice. Cute, cute. Yeah, bring me a pen.